possible values of a what's called a random variable, and it lists all those possible values for a random variable and the probabilities of each of those values. Okay, and let me just show you what one looks like, or what we'll try to make one look like as we go. Usually, along the top of the table, we're going to put x and then p of x, p parentheses x there. And like I said, I'm just kind of making these up. These happen to be the possible values in this scenario here, 1, 2, and 3. But alongside with that, you're going to put the probabilities of each. And the probability of 1 is 1/4, probability of 2 is 1/4, and the probability of 3 is 1/2. So this is what one's going to look like. And like I said, I just made that one up. It's not tied to anything at all, but just so you know what one looks like. This is what it looks like. All right. So, like I said, this is going to be the values that can possibly happen, and then this is going to be the probabilities of each value. 1 has a probability of 1/4, 2 has a probability of 1/4, and 3 happens in that case to have a probability of 1/2. All right, so let's do a couple of these, see what they look like. All right, let's say let's construct a probability distribution for the number rolled when rolling a single die. Probability distribution for the number rolled when rolling a single die. Okay, so like I said, the table starts out pretty much the same here. Do your x and then p of x on the other side. X, again, x means what possible values do we have. We're going to list out each possible value x could have. So in this case, x is what? The number rolled when I roll a single die. What are the possible values that I could get when rolling a single die? I could get 1, 2, 3, 4, 5, or 6, right? I could roll a 1, or a 2, or a 3, 4, 5, or a 6. This one's easy one, okay? Make sense? All right, then alongside that, though, we want to put the probabilities of each. So I'm going to go through each one. What would be the probability that I roll a 1 when I roll a die? What's the probability I roll a 1? It's 1/6, yeah. There's 1 1, and there's 6 total possibilities. Okay? What's the probability I roll a 2? It's not 2/6. It's 1/6 again, isn't it? Because there's 1 2 out of 6 possibilities. What's the probability I roll a 3? 1/6. Yeah, they're all 1/6. Yeah. Probability I roll a 3 is 1/6 because there's 1 3. Probability I roll a 4 is 1/6 because there's 1 4. With me on that? 1/6 all the way down. So this one isn't the most terribly interesting probability distribution, but it is what it is. Okay? Question or any concern? Let's do another. All right, construct a probability distribution. For the number of tails you could get when 2 coins are flipped. Probability distribution for the number of tails you could get when 2 coins are flipped. All right. We'll do our table. So x here, what is x? Well, x is the number of tails I could potentially get. All the different possibilities of number of tails I could get. Well, if you think about it, I could get just 1 tail, right? I could get 2 tails. And what else number of tails could I get? I could get no tails. So I could potentially get, x could be here, what? It could be 0, or 1, or 2. I could get 0 tails, 1 tail, or 2 tails out of the whole thing. So that's our x's. All right, now for the probabilities, we might want to write this down. Maybe should have wrote it down earlier, but what are the possibilities here? I could get heads, 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 tails, tails, heads, tails, tails. Okay. So what would go across from my 0 there? Well, think about what it means. This means 0 tails. So which ones of these have 0 tails? Heads, heads. So there's one of them that has 0 tails. 1 out of 4. So 1/4. What goes across from the 1? Well, that means 1 tail. So there's exactly 1 tail. How many of these have 1 tail? 1. Exactly 1. Yeah. Yes, it's exactly 1. I don't count this one because it'll go